In this video, we're going to talk about graphing quadratics when we're in standard form. Remember that standard form is when you order your variables from highest degree to lowest degree. So it would be y equals ax squared plus bx plus c. So if your equation in standard form is factorable, you can always start by factoring and finding the x-intercepts. But we're going to talk today about when our equation is not factorable, though this method works for any standard form, is we use this tiny equation, the opposite of b over 2a, to find the x value of the vertex. And then we plug what we found back into the original equation to find the y value. And you might recognize that the opposite of b over 2a looks familiar from our quadratic formula right here. This is the opposite of b. It's all divided by 2a. It's a part of our quadratic formula. And just like when we use the quadratic formula, we want to start by labeling our a, b, and c, then using that into this mini equation, opposite of b over 2a, to find the x. Then we're going to plug that back into our original equation and solve for y. You will recall that AOS is the axis of symmetry that is present for all quadratics. And what does it look like? It is a vertical line on the graph. It's an imaginary vertical line that goes through the vertex. And we just use that to help find our symmetry points on the other side when we're graphing. For our first example, we have y equals x squared plus 6x plus 7. And we're going to start by finding our a, b, and c, just like we do for quadratic formula. So remember, our a value is the coefficient of x squared. So when there's not a number explicitly written out, we know that that coefficient is 1, because 1 times x squared is the same thing as x squared. And then we're looking for the coefficient of x for b. So that's this whole part right here is a positive 6. And then our constant at the end is our c value, so positive 7. And the first thing that we do is we want to find our axis of symmetry. And that little mini formula is the formula that will tell us that. So the opposite of b over 2a, because remember, axis of symmetry is always a vertical line. That's x equals, and it goes through the x spot of the vertex. So if I'm taking the b value, which is 6, and I need the opposite of 6, that's going to be negative 6 divided by 2 times the a value, which is 1. That is negative 6 divided by 2, which is negative 3. So that's my axis of symmetry, x equals negative 3. And then my vertex is negative 3, and we don't know the y part yet. We have to plug that in to the original equation. So I'm going to have y equals x squared, so that's going to be negative 3 squared, plus 6 times negative 3 plus 7. And so you want to simplify that, so you can pause here and do that. And you will see that that is equal to negative 2. So what I do at this point is I start and I plot that point right away. So at negative 3 on the x and negative 2 on the y, so negative 3, negative 2 is this point right here. And I know that my a value is 1, and my jumps are a, 3a, and 5a. So it's going to be 1, 3 times 1 is 3, and 5 times 1 is 5. And I know that my parabola should be opening up because my a value is positive. So I can plot my graph with just this information. So I have, from my vertex, I'm going to go up 1 to the right 1 and put a point here. And then from that point, I'm going to go up 3 into the right 1 and put a point here. And from that point, I can go up 5 into the right 1 and put a point right here. And I can use my axis of symmetry. Remember, my axis of symmetry goes through the vertex, through the center of our parabola. And you can either count up in the other direction to put your points, or you can use the fact that this is symmetric and go across from your other point and be equidistant from your axis of symmetry. So whichever way you think is easier to plot that, you want your symmetric points to be plotted. And we're going to make that a nice, smooth U-shaped curve. So this is what we've done before. The only difference is finding our vertex a different way. And so I can see right here, I have my y-intercept where it crosses the y-axis. Let's label that X and Y. And so 0, 7 is our y-intercept. And I want you to notice something. We get the C value. When we're in standard form, that C value shows us our y-intercept. And that should make sense because if you put 0 in for X in both of those places, these two terms cancel out. So we'll always be just left with the constant. Now our x-intercepts do not hit at a integer value along my points for this example. And we talked about this before. So that means that the original polynomial was not factorable. That means we can find those approximate values by doing the quadratic formula. So I have that at the top of our page here. And let's go ahead and plug those in to get those values. So x equals the opposite of b. So b is 6. So the opposite of 6 is negative 6 plus minus the square root of b squared. So 6 squared minus 4 times a, which is 1, and c, which is 7, all divided by 2 times the a value, which is 1. So we are going to simplify what's under the radical first and get that simplified. So we're going to do 6 squared minus 4 times 1 times 7 first and put that under your radical. You can pause here to do that. Hopefully you got 8 like I did. And so because we're graphing this, thinking of this as negative 6 plus the square root of 8 divided by 2 and negative 6 minus the square root of 8 divided by 2 is not extremely helpful because I don't know what that number looks like. So it's going to be helpful to get a decimal approximation instead of leaving it as its exact value. So I'm going to break these apart and I'm going to do negative 6 plus the square root of 8 divided by 2. And if you're putting this in your calculator, I would do the numerator first and then divide by 2 to make sure that you're doing correct order of operations. And you're going to do that same thing again with negative 6, and then you're going to subtract the square root of 8 divided by 2. So take a pause and do that on your calculator and check your answers with me in a moment. So when I added, I got negative 1.5 and then a big long decimal that continued forever. That's irrational. That's because of the square root there. And then when I subtracted the negative root 8, I got negative 4.14 in a long decimal after. So when I'm writing my x-intercepts, I do not need to write that whole long decimal. I'm going to round so that I'm going to have negative 1.6 because 8 is bigger than 5. So it's going to round up with 0, and my other one I would write as negative 4.10. And you can see that that makes sense. Negative 4.1, it's a little over between negative 4 and 5. That's reasonable. Negative 1.5 is between negative 1 and negative 2. That is reasonable.